I'm not really sure where the video cut off, so I'll just finish up. We identify our discriminant. Our discriminant value tells us what kinds of solutions we're going to have. So if that b squared minus 4ac value is greater than 0, we'll have two real unequal solutions, so two different numbers. If it's equal to 0, we'll have one number repeated twice. If it's less than 0, we'll have no real solutions, and that's where our complex numbers come into play. We're not doing complex today, but we will be doing it next lesson, okay? So let's go ahead and apply this to an example, because I know you guys love that. I think some of you actually prefer quadratic formula. So we've got 4x squared plus x minus 3 equals 0. I can identify my values, so a is 4, b is 1, c is negative 3. I plug that into my quadratic formula. It is important to note that before we plug it in, we do want to pull out any common factors if we have them. Okay, we don't have any here, so we don't have to worry about it, but it will happen occasionally. Make sure you pull those out and simplify, and then identify your a, b, and c terms. So we get x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times negative 3 all over 2 times 4. Before we get too far, I want to find our discriminant value and identify the types of solutions we're going to have. So my discriminant is b squared minus 4ac, which here is 1 squared minus 4 times negative 3. And that is equal to 12. That does not seem right. I'm on the wrong line. 49. That's much better. Okay, so that's equal to 49. 49 is greater than 0, so I should expect two real solutions. So two different numbers is what I should expect as my answers. So let's see if it happens. So this simplifies into negative 1 plus or minus the square root of 49 all over 8. I can reduce the square root of 49 into 7. I can't do anything from here, so I'm going to split it into my two answers. Negative 1 minus 7 over 8 gives me a negative 8 over 8, which is negative 1. Negative 1 plus 7 over 8 gives me positive 6 over 8, which reduces to 3/4. So my two solutions are negative 1 and 3/4. And I'm just going to write that. Remember, when we list our solutions, we always list smallest to largest. Next example is 2x times 3 minus x equals 3. So this requires some manipulation to get it into our quadratic form. Distribute the 2x, I get 6x minus 2x squared equals 3. Rearrange, negative 2x squared plus 6x minus 3. Oh my goodness. If you wanted to, you could go ahead and multiply everything by negative 1 to get rid of the negative on your a term. You don't have to. Your answers will come out the same either way. I like to deal with positive numbers though. So this becomes 2x squared minus 6x plus 3 equals 0. Now I have my a, my b, and my c. We're going to go ahead and do our discriminant value just because I want to see what it comes out to be. You don't have to do this unless I ask for it, but it's kind of fun. So this becomes 36 minus 4 times 2 times 3. 36 minus 24 is 12. 12 is greater than 0. So I expect two real solutions, so two different numbers. And now we can go ahead and do the quadratic formula. So x equals negative of negative 6 is positive 6, plus or minus the square root of. I already found the discriminant, which is 12, and that's everything under the radical, over 2 times 2. So 6 plus or minus the square root of 12 over 4. I can reduce the square root of 12. I don't want to write it as a decimal because that's not an exact value, but I can pull out a perfect square because I recognize that the square root of 12 is the same as the square root of 4 times 3, and I know the square root of 4 is 2. So this becomes 2 times the square root of 3. So I'm going to rewrite this as 6 plus or minus 2 root 3 over 4. I noticed that I can simplify this because I can pull a common factor out of 6, 2, and 4. So all 3 of my values. I pull a 2 out and I get 3 plus or minus the square root of 3 over 2. And then those are my 2 solutions. I want them left in exact values. So 3 minus root 3 over 2 and 3 plus root 3 over 2. You can go ahead and do the next one if you want to. The discriminant comes out to 0. And when I plug in all the values, you get 5/3, and it would be 5/3 twice because 30 plus 0 and 30 minus 0 are the same. So that's how that one works out. I'm not going to do that one. Let's go ahead and do a fractional one though, because I know how much you guys like those. So I have 2x over x minus 3 plus 5 over x plus 3, and then equals 36 over x squared minus 9. On the left, I immediately identify that I can multiply this one by x plus 3 and this one by x minus 3, and that's going to give me a common denominator. So I'm going to have 2x times x plus 3 plus 5 times x minus 3 all over x minus 3, x plus 3 equals 36 over, well, this factors into x plus 3, x minus 3. When both sides of your equation have the same denominator, those are going to cancel each other out, okay? So I could essentially multiply both sides of this equation by x plus 3, x minus 3, and that's going to cancel out my entire denominator on both sides without changing any of my numerator values. So we can essentially just cancel them from each other, which leaves me with just the numerators, which is 2x, x plus 3, plus 5x minus 3, equals 36. Go ahead and combine, simplify, and put together. So I get 2x squared plus 6x plus 5x minus 15 equals 36. 2x squared plus 11x, subtract the 36 over, minus 51 equals 0. Then I can go ahead and do my quadratic formula, or we can go ahead and rainbow and factor this. I'm going to rainbow just because I think that that needs a little more practice than just the quadratic formula does. So when I do that, I can't pull out a common factor, so this 2 is going to get multiplied into the negative 51. X squared plus 11x minus 102 equals 0. I go ahead and factor this out into 17 and 6. Again, that's going to take a little bit of work, but that's okay. Still equals 0. X plus 17 and x minus 6. 17 minus 6 is 11. 17 times a negative 6 is a negative 102. I need to unrainbow the 2, so I get x plus 17 over 2 times x minus 6 over 2. This doesn't reduce, so I kick the 2 over, so I get 2x plus 17, and I get x minus 3 because that reduces. Last step is to set those both equal to 0 and solve. When I do that, I get x equals negative 17 over 2, and I get 3. So those are my 2 solutions. Our next example, we're going to use the quadratic formula, and then we're going to write our answers in factored form. Okay, so we've been writing them in set form. We're going to do it a little bit differently this time on this one, okay? We are almost done though. How much time's left in this video? Okay. So this next example, yellow still, is 21x squared minus 13x minus 20. I'm going to set it equal to 0 because I know I'm going to have to solve it. Okay, we can go ahead and do the quadratic formula. I'm going to let you work through the quadratic formula on your own. I'm just going to go ahead and work, so pause the video, work through it, and then come back and check my solution. So I went ahead and did all the simplification already, got my discriminant was 1849, square root of that is 43. Then I can split this into two answers, which is 56 over 42 and negative 30 over 42, both of which can be reduced. This gives me 4/3 because I can pull a 14 out of each of those, and I can pull a 6 out of each of these. I get negative 5 over 7. So my two solutions right now are x equals negative 5 over 7 and x equals 4 over 3. Okay, I want to write these answers in factored form. So the first thing I need to do is write them as x equals and x equals. Then I'm going to move them so they're with the x and have them set equal to 0. So I'm going to add 5/7 over, and it's equal 0. I don't like to leave it like this, so I'm going to kick the 7 over with the x. This becomes 7x plus 5 equals 0. Same thing over here. I'm going to subtract the 4/3. I'm going to kick the 3 over with the x. And my two factors are 7x plus 5 times 3x minus 4, and that's all set equal to 0. If you wanted to, you could go ahead and FOIL that out, and it's going to come out to be the 21x squared minus 13x minus 20. Okay? The next example in your notes, I'm not going to worry about too much right now. It is in there because sometimes we can have parameters. So I could say that I want you to solve this, but I only want where x is less than 1. Okay, so once I got my two solutions, I would have to ask myself, okay, which one, if either or both, of these answers is less than 1? Well, here it would be the negative 5/7, so this would technically be the only answer if I had that parameter or that requirement for the x value. Okay, so I'm not going to go through that example because it's not important and it's not on your notes. I mean your homework, okay? So then the last example, I'm going to try and get through it on this video. If not, I will finish it up on the next video. So it's a story problem. Given the height function is negative 16t squared plus 120t, where h is the height in feet of a toy rocket at t seconds after launch, when will the rocket be 180 feet above the ground? So the first thing I need to do is I need to know what my equations are. So I'm going to write it. H is negative 16t squared plus 120t, and I want to know after how many seconds will that height be 180? Well, super simple. We plug in 180 for the h and we solve for t. So I get 180 equals negative 16t squared plus 120t. Oh my goodness. This is clearly starting to look like a quadratic, so I need to move some stuff around. I'm going to move these left so that my 16 becomes positive. So I get 16t squared minus 120t plus 180 equals 0. Oh, let me beat this up. From those, before I solve it, I can pull out a common factor of 4. So I'm just going to divide it out because it's not going to change anything. So this becomes 4t squared minus 30t plus 45 equals 0. You can now go ahead and use the quadratic formula, or you could really try to factor if you wanted to. I'm going to say quadratic formula is probably going to be easiest. When we use the quadratic formula, I'm going to finish it up on the next video.